mathematicians. Today we're going to go over circles and just some brief definitions before we get started. The diameter is the distance of a line that starts at one edge of a circle. So if you see this green circle, let's say that line starts at point C. So it starts at one edge of the circle, goes through the center, and touches the opposite edge. So that would be point D. So C to D, or the line segment CD, would be the diameter of that circle. Radius is the distance from the center of the circle to its edge. And in green, that length is always going to be half the diameter. So if you were to look at this green circle again and notice the point OA, that would be a radius. The circumference is the length of the perimeter of the circle. So when you try to find a perimeter of a rectangle, right, it's the length of the sides all added up. For a circle, it's one continuous side. So you can't really add it up, and it's hard to measure. So what we do is we take their circumference, and to find that, we multiply pi times the diameter of the circle, which brings us to what pi is. So pi, and then you can see the symbol there, is the ratio of the circumference of a circle and its diameter. And let's get into the first example. So in the figure, O is the center of the circle with line segments AB, CD, and ED as shown. Name all the diameters that are drawn in the circle. So remember, a diameter has to go through the center of the circle. So which lines do that? It's not ED, right? Because that does not go through the center. But there are two lines that do. AB goes through the center, and CD, like we discussed earlier, also goes through the center. And to show that it's a line, I just put a line segment right across there. Part B asks which line segment that joins 2 points on the circle is not a diameter. Explain why it's not a diameter. So we kind of already talked about this one, but notice ED does not go through the center. And I'm going to just put O to represent the center. All right, question 2. The radius of a circle is 6 centimeters. What is the length of its diameter? So diameter we know is 2 times the radius, which means that it's going to be 2 times, and then the radius says it's 6, which 2 times 6 is 12. So the diameter of the circle is 12 centimeters. Next up, we're going to copy and complete the table. We're going to use 22 over 7 as an approximation of pi. So this is actually 22 over 7 is more accurate than 3.14. So it's better for us to use that fraction. So let's see, we have circle A, and sometimes it's easier to just draw out the circles, and we can label what we know. So let's make some circles. They might look a little bit more like ovals, but close enough. So we'll say that this is circle A, this is circle B, this is circle C. And then we can make an approximate center of each circle. For circle A, it says the diameter is 14. So that means that this length here is going to be 14. So if I know the diameter is 14, that means that the radius, which is half of the diameter, must be 7. And their circumference is equal to pi times the diameter. And if we do that math out, and let's do that math out just to the right of it here, we're going to use 22 over 7 as pi. 22 over 7 times 14. And now you're multiplying fractions. So you have 22 over 7 times 14 over 1. And since we're multiplying, we can cross reduce. 14 over 7 would be 2 and 1. So now we multiply across, we get 22 times 2, which is 44, over 1. So their circumference then is going to be 44 centimeters. Now for circle B, we're given the radius. So we know that the radius, which is from the center to the edge, is 21. That means that the diameter, if I were to make another radius, would be 21 plus 21, right? Or it's 2 times the radius. That means the diameter must be 42. And to find the circumference, we do what we did previously. Circumference is equal to pi, represented by 22 over 7, times the diameter, which is 42. Change them both into fractions. See if you can cross reduce. So does 7 go into 42? It does. 42 over 7. It's a 1 on the bottom, and then 7 goes into 42 6 times. And that leaves us with 22 times 6, which is 132, over 1, which is just 132. So we have 132 centimeters as a circumference. Part C is done the same way. I want you to do that one on your own, and then have your teacher check the answer. Then you can move on. Now we're going to briefly go over the area of a circle. So the area is equal to pi times the radius squared. And for these problems, why don't we use 3.14 as pi? So we can say that pi is approximately 3.14. So just find the area of a circle that has a radius of 18 centimeters. Since the area equals pi r squared, and we're using 3.14 for pi, and 18 is the radius, this becomes our next line. And as we simplify the problem, we're going to get 3.14 times 18 squared, which means you're doing 18 times 18, which is 324. Now you can do 324 times 3.14 if you want, but I'm okay if you use a calculator for this one. Just know that when you're doing it by hand, you do have decimals. And when you work with decimals, you remember you count how many digits you have to the right of the decimal symbol. because that's where you have to move the decimal point for your final answer. And either way, your final answer should be approximately 1017.36. So 1017.36 square centimeters, or you can say centimeters squared. The next problem is a little bit different. So we're finding the area of the quadrant. So now we're not given a whole circle, we're given part of a circle, right? So think of a circle, okay? You can also think of a coordinate plane. She's done this with graphing. Quad typically means four. So there are four parts. When you have a coordinate plane, there are things called quadrants. So this is quadrant 1, then 2, then 3, then 4. That's a coordinate plane. When we're talking about a circle, we still have quadrants. It's when we divide the circle into fourths. Okay, so we got a bit of a messy circle here, but there's my fourths. Okay, so you can see if we were to try to complete this circle, it's a more of a potato looking circle, but that would be about 1/4 of the circle. So our line that asks us to fill in the blank is the area of a quadrant is approximately, or is 1/4 times the area of the circle. That means we have 1/4 times pi r squared. Zoom in a little bit. And if we keep going, we've 1/4 times, we're going to use 3.14. And then the radius is 14. So 14 squared. And as we keep going with this problem, we still have 1/4 times 3.14 times, well, 14 times 14 is 14 squared. And when we do that all out on a calculator, we get approximately 154. So that's 154 feet squared. So the area of the quadrant is approximately 154 square feet. Our final example involves some real-world applications of circles. So a graphic designer creates a design for a company logo. The design is a green semicircle with a white quadrant as shown. Find the area of the green part of the design. Use 3.14 as an approximation for pi. So this can come into place in the real world when you are trying to figure out, maybe this is a design, a logo, and it's going to be huge. So you have to paint it. Or it's a banner for their logo, and you have to pay for color, right? But how much color, how much paint do you have to use? So say that you have to pay for paint by the millimeters squared that you use. If you're trying to estimate how much it's going to cost, then you have to do math like this, right? So what we're going to do is we're going to take the shape of the full semicircle, okay? And then we're going to subtract the shape of the quadrant, because the shape of that quadrant is not colored, okay? And it's kind of, you can think of it as on top of something that would be paint, but we don't need paint for that, okay? Or it's like a quadrant that's kind of taking a chunk out of that semicircle. So we're going to do the semicircle minus the quadrant. And now we have to find the area of each figure. So the area of the semicircle is equal to pi times the radius squared. But that's for a whole circle, right? So we actually don't want to use pi times the radius squared. We want half of that. So we would say it's 1/2 pi times the radius squared. And the quadrant would be 1/4 pi. And it's still times the radius squared, but we have a much smaller radius for that quadrant. And let's do these separately, and then we subtract at the end. So we've got the area equals 1/2. We're using 3.14 for pi. Okay, and a lot of these problems will tell you what to use for pi. And then we've got the radius squared. So the radius of this semicircle is 160. So it's the radius squared. And we keep on simplifying. So we've got 1/2 times 3.14. And then 160 squared is 25,600. And we multiply all of those numbers together, and we get approximately 40,192. And that's millimeters squared. And then we move on to the quadrant. So we have area equals 1/4, and then we're using 3.14 for pi. And the radius, so the radius of the quadrant is this length right here, which they give us as 30. So 30 squared. And if we keep going, we have 1/4 times 3.14 times 30 squared, which is 900. So that means that the area equals, and you can use the calculator to go through this, but it's approximately 706.5 millimeters squared. But we're not taking those figures together, right? We have the semicircle from the logo. That's the paint we're using, or that's the green that they're using in the logo. And we're subtracting the white quadrant because they don't need paint for that, for example, if you're trying to find paint. So the final step that we have to do is we take 40,192 and we subtract 706.5. And that comes to 39,485.5 millimeters squared. Okay, so that's the area of the green part. So you can do a lot of things, like I said, if you were trying to estimate the cost for paint and it was, say, 1 cent for every 1,000 millimeters squared, then you can do some math and figure out how much you have to pay for that specific logo, right? Also, are you going to scale that drawing up or that logo up, right? Because you could have the same logo on a business card or in a textbook that you could on a huge storefront, okay? But it would just be a much larger scale. And we're going to talk about scaling with area once we get to scale drawings. That completes our lesson on circles. And all that you have left is to do the practice problems that go with it.